So what we're going to do now is we're going to draw a Venn diagram to show the elements of the sets A, B, and C. So here are the sets that we've been given. I have kindly already drawn the Venn diagram for you. So what we're going to do now is just fill it in. So we have set A, which will be this one. We have set B, and we have set C, which will be this circle down here. Now, the important thing that we consider is our universal set. And remember, the universal set is dependent upon the question before you. So here, our universal set are the integers between 1 and 9 inclusive. So that means our universal set is 1, 2, 3, 4, 5, 6, 7, 8, 9. That's what they are. So that's the world in which we exist in. We only have these numbers here. We're not going to a million or a billion. We're just going from 1 to 9, which is great. Okay, let's now see if we can fill in this information on our Venn diagram. So A are the numbers 1, 3, and 6. B are even numbers, and C are my prime numbers. So it's important that when we're filling them out, we're always thinking, well, where is it going to overlap? So for our first one, A, the first number that we have to consider is 1. Now, 1 is neither an even number or a prime. So it's just going to be in this section over here. 3, on the other hand, 3 is a prime number as well. So not only is it a part of A, it's also a part of C. So it's going to be here. Obviously, it's not going to be in the part in which they all intersect because it's not an even number. All right, so we've done 1, we've done 3. The next is 6, which is a part of A and a part of B as well because it's an even number. So we're going to put it there. And just like that, we have filled out our first one. All right, next, we have to consider B and we have to think of all of our even numbers. So we're going to think about 2 first. So is 2 going to be a part of either of these? And it is. Remember, 2 is a prime number. So that means it's also going to be here. So it's going to be a part of my C as well, a part of my B. All right, the next one we would have to consider is 4. Now, 4 isn't a part of A, nor is it a prime number. So it's going to be over here. 2, 4, 6 is already there. 8. 8 is not a prime number and it's not a part of A, so it's going to be over here. And then we don't have to consider 9 because 9 isn't an even number. So we're all done there. Okay, so that's B done. Next, we have to consider our prime numbers. Now, we've already got 2, we've already got 3, so our next prime is going to be 5. And 5 is neither in A or B, so it's just over there. And then the next one we have to consider is 7. 7 is neither in A or B, so it's just going to be there as well. Now, the very important thing that you do after you've filled out all your sets is to consider whether or not you have included everything a part of your universal set. So here I have 1, 2, 3, 4, 5, 6, 7, 8, but I haven't included 9, have I? So that means 9 exists out here. So it's very important that you're considering that universal set and that you've included all the elements as a part of it. Okay, let's now see if we can answer these questions before us. The first is to consider B intersection of C. Well, B intersection of C is going to be this region right here, isn't it? And you know what? I can probably give this a bit of a shade. You probably can't do this, but I can erase very easily. B intersection of C is just here, right? So that means just 2 is going to be that. Now, when you're writing a set, you need to make sure that you include your fancy curly brackets, and it's going to look like that. Perfect. All right, the next thing that we have to consider, let's rub this out. Let's grab my highlighter again, is A, the intersection of C. So A, the intersection of C is going to be over here. And do you see how you've got an N there? What that N means is it doesn't want you to list the elements. It just wants you to say the amount that's in there. So how many elements? I'm going to write that down the bottom here. So I'll put this, how many elements. So not the elements themselves, but just how many elements. And as you can see, how many elements are in A, the intersection of C? There's just 1 in there. So I just put 1. So again, it's not asking for you to list the elements, but the amount of elements. That's what that N is telling me. All right, we continue on here. Let's get rid of that. We'll come over here. This is asking me for A, the intersection of B, the intersection of C. So it's the place in which A, B, and C all overlap. That's going to be this part right here. And as you can see, there are no elements here. Now, the reason why people make a mistake here is because what they do is they put like a 0 there. But if you put a 0 there, I mean, it's just wrong, isn't it? Because 0 isn't an element, nor is it asking you to list the amount of elements. So what you're going to do is you're going to say it's a null set, because there's nothing there. So if you remember back when we went through all our symbols, we talked about the null or the empty set, and it looks like that. So that's what you're going to put in if you're ever given a set that contains no elements. All right, we keep soldiering on here. The next is A, the intersection of everything that is not B. So A, the intersection of complement B. This sometimes, takes a while just to think through. So let's just do some shading here. So I've got A, so everything in A is this. And then I've got everything not in B. So everything not in B, so the complement of B, that's going to be everything here. Again, this is just really rough, isn't it? But that's okay. Then we can look at this and say, well, where do these overlap? So they overlap just 1 and 3, isn't it? That's the only place in which I've colored both. So I come over here, again, I put my fancy brackets, 1 and 3, and I close off my fancy brackets. All right, then I'm going to get rid of all this highlighting. Perfect. Next, I have A, the union of the complement of C. All right, so let's first consider A. So A is going to be everything in this. Then I'm going to consider the complement of C. So the complement of C is everything not in C. So it's going to be everything here. Don't highlight C. Everything over here. Okay. Now remember, union means everything in A, everything in the complement in C, and also where they overlap. So in other words, it's just everything that you've highlighted here. So it's just everything that you've highlighted here. So what we're going to do now is we're going to come over here, and I'm literally just going to write down everything that I've highlighted, because the union of two sets is just everything that's there. So everything that I've highlighted. So let's go and we'll do them in order. So it's going to be 1. It's not going to be 2 because I haven't highlighted 2, but it's going to be 3. It's going to be 4. It's not going to be 5 because I haven't highlighted 5, but it's going to be 6. It's not going to be 7 because I haven't highlighted 7, but it's going to be 8. And then it's going to be 9 because I've highlighted that as well. So it's going to be 1, 3, 4, 6, 8, 9. I close off my brackets. Whoop, they're pretty ugly. Just like that. All right, let's get rid of that. Let's get rid of that. Perfect. Next is A, intersection of C, and the union of A and B. All right, so let's just first consider this bit by bit. So where do A intersect C? So that's going to be here. That's the intersection of A and C. Then I need to consider everything that is in B. So I come over here. So everything that is in B is this. And remember, if it's a union question, it's literally saying, list everything that you've highlighted. So I'm going to say everything that I've highlighted in this case would be 2, 3, 4, 6, and 8. 2, 3, 4, 6, and 8. So again, remember with unions, it's just everything that you're highlighting. So 2, 3, 4, 6, and 8. Amazing. Let's get rid of that. All right, next is B, and then I've got a slash, and then I've got brackets, A, the union of C. So this is B excluding this part right here. So the way that I kind of think about this, and remember, we saw this as being the set difference. So if we were to write down what it is exactly, so let me come here. So it's B excluding A, the union of C. So that's kind of how I read what this is saying here. All right, so I come over here and let's consider this for a moment. So what is, and I'll use my colors because that's helpful. Let me highlight B. So B, I have all of this. I have this, I have this, I have this. So I've highlighted everything in B. Then I'm going to highlight A, the union of C. So A, the union of C will be this, all of this, won't it? So everything that's a part of A and C. But now what I want to do is I want to eliminate everything that's highlighted in green because there's B excluding A union of C. So I want to get rid of, whoops, I didn't want to get rid of that. Oh, undo. There we go. Let's try again. I want to get rid of that. Oh, whoop. Let's see if I can do it one more time. I want to get rid of all of that. So everything in green that I've highlighted, I want to get rid of. There we go. So hopefully you can see that it's just going to be this 4 and 8 right there. All right, so let's come over here and let's put that in. 4 and 8. Remember your curly brackets. Okay, and that's what it is there. So hopefully you feel confident in doing this. So using a Venn diagram and just working through that procedure that we've seen there.